Good evening, honorable judges of CYS Indonesia. My name is Xaverius from Laurensia High School, Alam Sutra. In this video, I'm going to present my research titled A Study of Biomimetics Implementation to Increase Flight Endurance of Unmanned Combat Aerial Vehicle Elang Hitam. UCAVs have played an unprecedented role in the 21st century to serve both military and civilian purposes. Indonesia is currently developing its first UCAV, called Elang Hitam. This could be a stepping stone for future development in unmanned technologies made in Indonesia. But there's one problem. This UCAV has not been deployed to any operations or flight testing, whereas when we compare with other UCAVs worldwide, all have been deployed to uncountable high-risk missions. One crucial parameter of a UCAV that determines its survivability is flight endurance. But there's one factor that seems to haven't been considered yet. It is climate conditions. Indonesia is located on the equator, which means average air temperature could be high all year round. High air temperature could significantly reduce flight endurance by reducing its propeller efficiency due to thin air. So what can be done? The aim of this research is to propose a low-cost solution. One way to do it is through biomimetics. We could mimic the flying technique of birds instead of buying a new engine. One solution is using thermal soaring, a form of flight in which an object takes advantage of convection thermal currents to be able to fly without engine power. There are two methods proposed in this research. The first one is advanced autonomous soaring. It works by generating a computerized map based on these parameters to determine the waypoint, airspeed, and turn rate of the aircraft during thermaling. To explore the thermal, it uses two methods, local and global exploration. Now, to use the thermal, the aircraft's current McCready value is matched with a certain threshold of the thermal cell strength. Then mathematical formulas are used to locate the thermal and to control the aircraft during centering. The second method is the peregrine falcon strategy. It mimics the bird's direction-changing strategy in order to map the thermal region more efficiently and gather updraft information from the past to estimate the next possible optimal thermal location. Since it is not possible to conduct direct flight tests on the UCAV, this research will analyze the results from previous studies. Michael J. Allen and Daniel J. Edwards are able to increase flight endurance of a small UAV and develop methods of accurate thermal estimation. A group of research from University of Hungary tested both methods and found that the following result. One major advantage of using the peregrine falcon strategy is reducing computational power and complexity, which is crucial for UCAVs with limited power on board. In conclusion, this research recommends the implementation of both thermal soaring strategies on Elang Hitam. Future applications could include search and rescue, disaster mitigations, border patrol, counterterrorism, and many more. Thank you.